Section 1.8 is on functions as graphs. Functions as graphs. And then I want you to pause the video and take a minute to copy this figure right here into your notes. So give yourself a coordinate plane and plot the points as they're shown here. So we've got points at 1, 3, 2, 1, 3, 4, 3, -1, 4, 2, 5, 0, and 6, 6. So pause the video real quick, copy the graph as well as what it says in part A there, list these points on a table. Once everybody's ready, you can restart. All right, so part A, list these points on a table. So we're going to make a nice big XY chart, and we're going to list the points. So this point right here has an X of 1 and a Y of 3. 1, 3. We did that one, so I'm going to cross it out. 2, 1. We've got 3, 4. 4, 2. 3, -1. 5, 0. And that point up there, that's almost off your screen, 6, 6. So that's just a matter of taking the point, rewriting it onto a table. Parts B and C we did last time. We know how to state the domain and state the range. When we state domain and range, we write them as a list of values, a set of values. Domain is the set of inputs, which is the X values. We list them from least to greatest. Smallest one's 1, then 2, then 3. 3 occurs twice. I'm not going to write it twice. And then 4, and then 5, and then 6. And then we close our curly bracket. The range, we do the same thing, but now we're looking at the outputs, the Y values. Our range is -1 is the smallest one, 0, 1, 2, 3, 4, and 6. Again, we did problems like this last time where we were given a table, we stated domain and range. We also talked about how to state if a graph is a function or not. And to tell if a graph, I guess we didn't talk about a graph, but how to tell if a table is a function or not, is we look at all the X values and we're looking for, are there any X values, are there any inputs that have more than one output? The input of 3 has an the input of 1 has an output of 3 and only 3. The input of 2 only has one output. The input of 3 has an output of 4, and it also has an output of -1. If we have an X that has more than one Y, then we can stop right there and say, no, this is not a function. This one is not a function. Our goal for today is to be able to answer part D, is the graph a function or not, without having to do these intermediate steps. We shouldn't even have to do part A. We should be able to look at a graph and tell if it's a function or not a function, just by looking at it or doing something with it quickly. And what we're going to do is called the vertical line test. The vertical line test. Yes, this should go in your notes. The vertical line states if any vertical line, a vertical line, remember, is one that goes straight up and down, passes through a graph at more than one point, then the graph is not a function. If any vertical line passes through a graph at more than one point, then the graph is not a function. Vertical line, straight up and down line. If there's any point where a vertical line passes through the graph more than once, then that graph is not a function. And as always, if I move on too fast, pause it, get caught up. So going back to this example, the previous example, example 1, I'm going to take a vertical line. A lot of students will just, if the graph's in front of them, they'll just take their pencil and hold their pencil up and down so that it's vertical. And what we're doing is we're looking, is there anywhere I pass through more than one point at the same time with a vertical line? Notice right here, I'm only passing through the graph once, right? Just that one point. That's okay. Here, I'm only passing through one point. That's okay. But when I get right here, notice I pass through two different points. I can stop right there and say this is not a function, which is the same result we had down here. No, it's not a function. And the reason for that is when I take a vertical line, what I'm doing is I'm testing that x value. I'm testing an x value of 2. And I'm seeing how many times does the graph have an x value of 2? Well, only one time it has an x value of 2. Only one time it has an x value of 4. But 2 times it has an x value of 3. And remember, for it to be a function, each x could only have one y. Well, the x value of 3 has two y's, -1 and 4. -1 and 4. So that's why the vertical line test works. Well, let's take a look at using the vertical line test on some graphs. I want you to sketch these in your notes. They don't have to be perfect, but give me a coordinate plane and then sketch in that parabola that opens down. Should look something like that. Again, it doesn't need to be perfect. And we are going to take a vertical line, a straight up and down line, and we're checking to see, is there anywhere that I put a vertical line where it passes through the graph more than once? So notice if I put that vertical line right there, it only passes through the graph right here. And it only passes through the graph here. And just one time. And just one time. And just one time. And just one time. There's nowhere I put this vertical line where it's going to pass through the graph more than once. Every single x has one y. This one is a function. Yes, it is. Again, spend 12 seconds sketching in that graph. Coordinate plane, circle. Notice right now, if I put that vertical line right here, I cross through the graph 2 different times, one up here and one here. This one is not a function. So if there's any vertical line that passes through the graph more than once. Notice it also happens over here. I don't need to keep checking, but this one's got lots of places where if I move that vertical line, it crosses the graph more than once. As soon as I find one point that's like that, I can stop and say it's not a function. Just like this one over here, not that, right here. This vertical line right here passed through the graph more than once. Let's talk through a couple more. This one, we've just got a straight line. If I take a vertical line, no matter where I put that vertical line, it only crosses through that line once. Now remember, this is the coordinate plane down here. That's not part of my graph. But there's nowhere I put a vertical line that it crosses through that line more than once. This one is a function. What do you think about this one? If I move that vertical line around, and again, you can just hold your pencil against the paper if you have the drawing on your paper. No matter where I put that vertical line, it never crosses the graph more than once. This one is also a function. Those are both yes. Let's think through a couple more. Got 3 here. I want you to make a decision on each of those. Is it a function or is it not a function? Pause the video, think about it for a couple minutes, restart for answers. This one over here, no matter where I put that vertical line, I won't find any point where I cross through the graph more than once. Yes, this one is a function. This one, if I put that vertical line right there, notice I cross through the graph here, cross through the graph here, cross through the graph here. Not a function. This last one, no matter where I put that vertical line, we only cross the graph once. This is a function. So these outside ones are functions, the middle one is not. That is it for today's notes. Reach out if you have questions.